Already we have discussed what is mean by protocol and what is the use of protocol, what are the different protocols we have based on the frequency and bandwidth, how we will use the protocols in a SOC level, right? So can you tell me anyone what is mean by a protocol, how to use? Group of instructions. What instructions? What instructions we have? Can you unmute and can you talk? What instructions we have? Hello. Can anyone tell what is mean by a protocol? When your exams will be completed, Ramni?
Tomorrow, ma'am.
Then why don't you tell me before? You told yesterday is last exam. If you tell me before, then I can schedule tomorrow only, right? Tomorrow evening. Tell. Tell what is mean by a protocol. We already discussed. I have shared the video also.
Hello, I am Luda.
Yeah, hi.
Yeah, yeah. Protocol means it's a set of rules we need to transmitting from one device to another electronic device.
Okay. Yeah. It is a set of rules, right? Set of rules is nothing but how can we transfer the data? Suppose a set of rule in the sense from which component to which component you are sending the data, from which device to which device you are sending the data. Suppose it is a internal device to the system or external device. Internal device means what? There will be a motherboard. Okay, this is the SoC, or you can treat as a motherboard. In the motherboard there will be a processors, there will be a graphic processors, and there will be a memory units, and there will be some camera modules, and there will be some related to protocol, like related to the systems which are used for graphics and all, like memory subsystems, like that. Okay, so suppose I want to communicate with a processor to the camera module. Okay, every module or every component will be connected to the processor, because processor is the heart of the computer, right? So whenever the camera module is communicating with the processor, whereas processor is the very high speed, it will work under high bandwidth. Camera module, it's just a small component, right? So just a small component means it doesn't have that much bandwidth. It doesn't work on that bandwidth. Okay, it will work just a small minimum bandwidth. Okay, so that time when you want to communicate with the camera module to the processor, this side we need to use according to that bandwidth, according to that functionality, because whether it is communicating serially or whether it is communicating parallelly, like that we need to check. Okay, and there will be some other ports like UART, USB ports will be there to our laptop if you see, or if you see mobile phone, there will be a C type or B type cable connection will be there here, some socket type. So which type of protocol you need to communicate? Suppose here there is a USB port. Okay, USB port means which is a high bandwidth only. Okay, but whereas USB is a serial communication protocol. Okay, but whereas processor, if you want to communicate with the processor, it will take a parallel data. Okay, so how to use these type of protocols, how to classify these type of protocols, we already discussed all the things, right? So those are the set of the rules we need to follow. Okay, suppose if you take, I will share you both of you, I have discussed previously what is mean by protocol in SOC, how to use those things, I will share you that link. See, suppose if you take this is a motherboard or a SOC. Okay, there will be a interfaces, these are the interfaces connecting between the different components internal SOC. Okay, if you want to communicate with a laptop to the microcontroller, or if you want to communicate with a laptop to our mouse or a keyboard, how you are communicating? We are using the USB ports. Okay, that is nothing but intra communication system which is outside to the device. Okay, so those types of protocols we are going to use. Okay, suppose I am communicating with a processor to the suppose here use or a timer is there, whereas processor uses high bandwidth, we need to use the high bandwidth protocol here, which is a parallel communication, nothing but AXI. We have three parallel communication protocols like APB, AHB, AXI. Right. So AXI is the parallel communication protocol with a high bandwidth. We need to check the bandwidth accordingly. Okay. Suppose APB is the very less bandwidth. Okay. So APB you need to use a less bandwidth components. Okay, like that. Did you got the clarity now, everyone? Did you got the clarity, everyone, now?
Yes.
Okay. Can you tell me now, Ramni, what is mean by a protocol? It is not a instructions. Uh, Group of instructions to do a function. Okay, it is look like embedded language, but it is a set of protocol which is used to communicate. Okay. Next, in the session in Verilog, as we discussed, we are going to cover 5 protocols and 2 projects, right? So in Verilog, we are going to discuss 1 protocol, 1 project. Today we'll discuss a 1 protocol. By weekend, we will discuss 1 project. Already you did very late. You are not attending for the session because of your exams and all. So if you told today that you have exam tomorrow, then I will take tomorrow only, right? So many students are missing now because of you only. I waited for these many days because these are the protocol everyone have to listen, which is very important, that's why. Why tomorrow? Yesterday, previously also you did same thing. I scheduled the session, I joined the session, and then you didn't join. Okay, let me explain some why we have to close the session. Okay, see. So protocol means it is a set of rules. I thought today I have to complete overall UART, even code also. but you are wasting so much time. Okay, see, protocol means it is a set of rules and regulations. Different type of protocols are available. As I said, now there will be a bus protocol, which is a parallel communication. Bus is nothing but there will be 32-bit, 16-bit, like that, right? So by using the bus we can communicate, okay, based on the bandwidth. APB is a low bandwidth, AHB, AXI. By end of the course we will discuss these three. APB we will discuss in system Verilog. AHB and AXI we will discuss at the time of UVM. Okay, so peripheral protocol or nothing but interface protocols we can call, which are the serial communication protocols. In that we are classifying as a high speed and low speed. High speed or PCIe, SATA, Ethernet, USB, these things we will use in the industry only. Okay, PCIe is a very high speed protocol compared to the I2C. I2C, if it works at 10% means PCI works at 1000-2000%. Okay, so that much of speed it will work in your SOCs or motherboard, whatever we are using. All those works under PCIe only, serial communication. Okay, like that USB ports you are using present. Previously, olden days we have used UART. Okay, so you ought to have so many disadvantage limitations, so that's why now we are using USB, which is a industry level protocol. No need to learn now. Once you go to the industry, all these things you will get in the project. Okay, and low speed protocols are your I2C SPI. As a student level we can learn this to get the idea about the protocol. Okay, today we'll see about the UART protocol, and you can go through this concept. I already discussed very clearly. I have shared the SOC concept also on protocol. I will share this PDF, you can go through that. And coming to UART protocol, what is mean by UART? What is mean by UART? UART means universal asynchronous transmit receiver and transmitter. Okay, it is a asynchronous protocol. What is mean by asynchronous protocol? What is mean by asynchronous protocol? Asynchronous means we don't have any clock, right? So without a clock, how a system will be communicated? How the transmission will be happen between a transmitter and a receiver without a clock? Can
By the
anyone?
channel.
Either channel, okay, okay. Channel means here. What is mean by channel here? In channel also there will be a clock, right, to communicate between a transmitter and receiver. There will be a clock.
By reset.
Reset, all these are signals, but without a clock, if you have reset and all, what is the use? If there is a clock, there will be a synchronization between the transmitter and receiver. Okay, if there is no synchronization, what happens? We won't get the data at a perfect time. Okay, at what time the transmitter is sending the data and what time the receiver is receiving the data, there will be a mismatch in the timing if you don't use the clock. If you use the clock, the output have to receive at this particular time only, at this particular passage or at this particular negate. We have that confidence at what time it should get, but without using the clock we don't know at what time the data will get, right? So it is a first protocol, it is a basic protocol. In this we don't use clock, it is a asynchronous protocol. Okay, later on I2C, APB, AHB, these all we have used the clock, but in UART there is no clock. Okay, so UART protocols is a serial communication two wire protocols. And there will be a receiver and there will be a transmitter. Serial communication will be happen. Serial communication means one by one, bit by bit. One bit transmitted to receiver, then second bit, then third bit, then fourth bit. Like that, one by one bit will be transmitted. Okay, the UART takes bytes of data and sends the byte in a individual bit manner. Okay, suppose UART is accepting a uh, 2 byte. 2 byte is nothing but 16 bit. 16 bit means it will send 8 bit at one time, and after completion of 8 bit, then it will send another 8 bit. Okay, so that is UART protocol. And coming to UART is a half duplex protocol. Can you tell me what is mean by half duplex?
At a time, only one way is passed.
Okay. Uh,
Only
not a,
transmit. There is no receiving.
mm, okay. There will be transmitting and receiving, but not at the same time. Okay. Once
Oh,
transmission has done, then we have to receive the data. Transmission and receiver not happens at a time. Okay. So mostly all the protocols like this only, I2C or APB or AHB, all these protocols are like this only, but AXI we don't have a half duplex protocol. It is a full duplex protocol. Okay, that means both transmission and receiver. Transmission and reception is nothing but write and read operation. Okay, can be done at a time. So in half duplex cannot be done at a time. Once write operation completed, then we can read the data. Okay, so half duplex means that, and it is used the single line transmitting and receiving data. So for UART we will use the frame format. This is the frame format we will use for UART. Okay, like that I2C there will be other frame format. APB has some other format like FSM, AHB some other format. Like that we are going to send the data from different components by using these structure. Okay, so these are the protocol. That means this format means in this format only we need to send the data. That is the protocol we need to follow. That is the rule to say to transmit the data between different components or devices. Okay, now we'll see what is the rule for your protocol. So this is the frame format. In this format only we need to send the address and data. First one is it is a total 11 bit format. Okay, first bit is a start bit. Okay, first bit is start bit and last bit is the stop bit. Whenever start bit is high, it should start sending the data. It should write the data. Whenever stop bit is 0, it should stop to accept the data. It doesn't send the data to the slave. Okay, there will be a master and there will be a slave. Master is nothing but which is transmitter. Slave is nothing but receiver. Okay, master will send the data to the slave and slave receives the data from the master. It will respond, slave will respond to the master. Okay, whatever the signals, control signals or data signals, whatever master will send to the slave. Okay, and between these is data. Okay, in UART we will send 8-bit data. And last one is parity. Parity means what we already know. We already learn even parity, odd parity, like that, right? Even parity, odd parity means by using those we are going to check whether our receiving data is correct or not. Okay, if you are using odd parity method, in that we have to check all ones receiving odd or not. Okay, once if we don't receive all ones as a odd, it will be error. Okay, it is a old parity method. Because why old method means we don't know, suppose in transmitting side we are sending this data. Okay, 3 1s 1 0, and receiver side also we are receiving this data, 2 1s 0 and 1. Okay, but here 3 1s, here 3 1s, both data are same. both data are not same. Okay, but it is the limitation for that. Okay, we are checking only how many ones are there. Is it odd or is it even? We are checking only that thing in the UART. Some other coming to I2C UART, coming to advanced level protocols, all the things are changed. Okay, error detection and error correction methods all are changed. But in UART we have used the parity method, which is the oldest one. It has so many limitations. Okay, did you got the point, everyone?
Yes, ma'am.
Okay, so this is the frame format. When we are writing the program, you can use this frame format, but we are not using this frame format. We have the structure for your protocol. We are using the structure and you are writing the program. Okay, so this is the in interviews they will ask, can you draw a frame format for your? Can you draw a frame format for I2C? Can you explain the functionality of UART and I2C or APB? How the APB works? What are the states? Like these questions they will ask. Okay. So we are covering all the question. I will try maximum. I will cover all the questions in the session only. So that is the frame format. And this is how the UART communication. UART is the intra protocol. Intra means within the system to outside the system it will communicate. Okay, it is the peripheral is nothing but within the system, SOC, to the outside system. We have the ports here, right? For the laptop, we have some ports, USB ports now. In previously, we have used UART ports. Okay, through those ports we will connect to the microcontroller or to any of your joysticks or microphones or to the scanner or printers or whatever you are connecting. So it is a external device connector, this protocol. Whereas I2C SPI, these are internal. That means within the SOC, suppose this is the SOC. Within component to component communication, we'll use I2C like that. Okay. Have any doubts up to now?
No, ma'am.
Okay. And two UARTs communicate directly with each other. Transmitting UART converts parallel data from a controlling device like a CPU to internal stream, transmitting in serially to the receiving UART. Receiver UART then converts the serial data back into the parallel receiving for receiving device. Okay, what is mean by that? Suppose this is my total SOC. Okay, this is my laptop motherboard. If I think this is the processor where I have. Okay, and here I have a port, USB port or a yacht port I have, port I had. Okay, and through from this yacht port, I'm connecting to the device. Okay, here there is another microcontroller, or here there is some other device, whatever you will connect. Some suppose phone, mobile phone. You will connect your mobile phone to the laptop, right? So from your mobile phone C type pin or any type port will be there. To that port to your port you are connecting. Okay, so in mobile phone also there will be a processor here. Okay, processor or memory unit, whatever, there will be a processor, right? So this processor accepts the data which is a parallel data, right? This parallel data is coming to this UART port, but from this UART port and your phone UART port, they don't accept the parallel. They will communicate serially, but if your C type port to processor again parallel. These are parallel, here also parallel, but here serial. So what it do, your master side, it is getting parallel data and it is sending that parallel data is converting to the serial. That serial data is converting sending again to the next port. From this port again the data have to convert parallelly to send to the processor. Did you understood this thing here? That means to send for this communication here, only this point we are using UART protocol for serial transmission. Okay, but here wherever it is transmitting from parallel to here, we will use AXI protocol, AXI or AHB, which is a bus protocols. Here we will use AXI interfaces. Okay, did you understood everyone?
Yes, ma'am.
Have any doubts? Jashwant, have you joined? After so many days, I think, right?
Yes, ma'am.
Okay. Okay. Did you understood everyone? The functionality here, how we are using the protocol?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. If you have any doubts, you can ask me. Next, just go through the theory. Whatever I have explained, everything is there here. Start bit, stop bit, what is mean by that? Whatever we explain, what is mean by start bit. Okay, data bit like that. And stop bit. I will share the PDF. You can go through that, how it is working. Okay. Another thing, I told you, your doesn't use the clock. Okay, if it doesn't use the clock, how the synchronization happen? How the synchronization happen means we will use the baud rate here. Okay, the data frame, whatever we are transmitting serially, it redefined clock rate. We will define one clock rate to the data. Okay, based on the clock rate only, the data will be transmitted from transmitter to the receiver based on the baud rate. Okay, I will tell you what is mean by baud rate and all. So the receiver is default at a high logic state, which indicates the ideal state. Receiver and keeps looking for high to low transmission. That is nothing but start bit. Okay, always receiver looks for start bit and stop bit. You can go through all these things. Coming to the implementation, how we will implement the Verilog, how we can implement the UART in a Verilog. Okay, so this project is divided into three main modules. Okay, what are the three main modules? We will have UART transmitter, UART receiver, and one another thing is baud rate generator. Okay, we will generate the baud rate also. There will be so many methods for baud rate generator. We can generate the baud rate by using the equations and all. Otherwise, there are standard baud rates also. Okay, standard baud rates means already whatever your protocol, some of the scientists have defined the baud rates. Okay, we can use this protocol under these baud rates. We can generate the clock under this baud rate. Okay, so there is a specified baud rate. You can use that baud rate, or you can generate the baud rate also. Okay, so these based on the three modules we are going to write the program. Okay, and these three modules further divided into the sub modules. All these modules are connected by instantiating each module. Okay, so this is the block diagram we have for your protocol. You can write the program using the frame format or using the block diagram also. Frame format you can write easily, but you don't know how to write using a block diagram, right? Because there will be so many signals will be there. So we'll discuss these things now, how to write the program using the block diagram. Okay, so this is the baud rate generator and your receiver and your transmitter. Okay, we'll discuss one by one. First one, baud rate generator. Okay, first baud rate generator means what we have. There will be selection signal, clock signal, reset signal, and next bit. Okay, so for asynchronous communication, we will use this baud rate to make the synchronization between transmitter and receiver. Okay, it is a number of symbols per second transmitted. It is a number of symbol. Symbol is nothing but a 16-bit or 32-bit, like that group of bits. Okay, so each bit is 1 by baud rate wide. 1 by baud rate wide. Baud rate is equal to clock frequency, whatever the clock frequency you want to take, that clock frequency divided by 16 into divisor. Okay, so this is how we can calculate the baud rate. Not only this method, there are 2-3 methods also. I will tell you the 2-3 methods. Okay, and there are some standard baud rates like 2400, 9600, 19200, 38400, 115200. These are the standard baud rates we have. Okay, you can directly use this standard baud rate to your project, or you can generate the baud rate. Okay, next, have any doubts? Okay,
No, ma'am.
next, coming to the UART transmitter, second module. In this UART transmitter, we have one finite state mission, one parity generator, parallel input, serial output, and one multiplexer. Okay, so this is the block diagram for transmitter. Same this block diagram, we are going to do the programming. Okay, can you join for the next session quickly? Same link, using the same link. Can you join quickly again?